Right away. Hi everyone, I'm swyx. Hope you're having a good build so far. Okay, I'm going to start with maybe something slightly controversial, which is somewhat making fun of a launch of Microsoft. This is the GitHub Copilot app, which is launched a couple weeks ago. And it's basically their big rebrand of what Copilot could be at, beyond VS Code. And you notice like it looks interestingly similar to some other apps that have been launched recently. And the way I frame this is that everything is conductor. The conductor was kind of first to this form factor of being an agent command center. They all have this marketing line. And then eventually sort of Cursor rebranded, Windsurf rebranded, Codex rebranded, and GitHub rebranded. And I think this is just less an indictment of the lack of imagination or whatever, or it's just more or less the form factor that everyone has agreed that we're going to converge on. This is very similar to everything becoming a crab. We've sort of independently reinvented the crab at least 7 times on Earth. And so I think that is the sort of main focus that I was sort of pitching this talk, I guess, when I was invited to come speak. And very ironically, the company that I'm advising, Cognition, recently, yesterday, also shipped the Agent Command Center. Guess what? It's the same other thing as well. It's got some other interesting features with the local to cloud handoff. But fundamentally, the level of abstraction is really shifting from managing individual agents. We started with like autocomplete and starting to manage like individual terminals, starting to tmux the terminals and have like 12 different terminals going on. And then something more civilized and organized like this. My own coding definitely looks very chaotic in a similar way, which with all these agent managers as well, but also multiplexing across Cursor, across, oh my God, I just published my GitHub tokens, I gotta rotate that. And all the Cloud Code instances over there as well. So that's great. I think like one of the things that is very interesting is like, it's discovering why we're here, right? So I spent a lot of my career basically organizing the AI engineer community, and I've been sort of watching this over the last few years, and especially over the last year. This is an explosion in the community. I've met people across Paris and London and Miami and Singapore and all these, and there's basically like 6 core themes that I really wanted to impart on people. And I think this is all the contributors to what exactly is going on and where we're about to go with all this, right? I think there's a little bit of like anxiety. One of my speakers in one of my conferences called it FOMAT, fear of missing agent time. Literally, like people are doing like polyphasic sleep. Like I wake up at like 2 a.m. in the morning and go like, okay, well I can just go hit enter on my agent again and before I go back to bed. And I think like really what is becoming true is that people used to be sort of in the sort of big model religion, and it is no longer that, right? It is sort of this model plus harness combination, which I think is very wonderful for developers like yourselves, and really is this idea that you can actually have a strong influence by shaping the harness in whatever way. It used to be prompts, but now we have so many other additions from MCPs to skills to workflows to what have you, and I do think that requires a different kind of UI to interact with the model apart from just chat, which I think is what we're seeing as well. We're seeing also the model labs really transition themselves from just being like we're going to output the pure model towards harnesses that are usually increasingly more and more swarm oriented. You can see 𝗦𝗽𝗲𝗀𝗃 put out like hundreds of parallel swarms. Anthropic recently also released the embarrassingly parallel feature to port their million-line code base of Zig into Rust. And I think that's a sign of things to come. I also think that there's also just going to be a lot of humans employed in this area. So like I think there's some job security there. And it's funny enough, like it's not even like the code base of the agents that is valuable, because you can leak the entire source code of Cloud Code and nothing changes. Okay, and what do I mean by nothing changes? Anthropic becomes $1 trillion company even after all the source code is pwned. But also, like I asked the makers of all the other competing harnesses, did you learn anything from from the Cloud Code source leak, literally on my podcast the other day, and they were like, no, like it just validated they have no secret sauce. Like we are also doing the same thing. We've also discovered the same exact thing. So the moat is not in the model anymore. The moat is not in the sort of the agent harness. What actually is it? And I think, obviously that the conclusion is that you want to orchestrate multiple agents and really do the mind meld of human to agent. Other trends that are really interesting, I do think that the reason that this is so much enabled now is because you can kind of be hands-off with a lot more model work. And it only recently happened. Is anyone familiar with the site WTF happened in 1971? It's kind of like an old economics site. There's like one econ guy. Anyway, if you're interested in economics and history, there's a site that is very famous for documenting like the sharp transitions in econ over the last 50 years. I think there's another transitioning happening right now, and it happened around about late 2025 that we're living through the implications of it, and that is mostly because models have transitioned from being like requiring a lot of human in the loop. Here, it's shown by meter to be capable of 1 to 2 hour tasks, suddenly jumping to 10 to 12 hour and over 24 hour tasks. When that happens, when you have like that 10x in autonomous capability, you start to have different kinds of UX, and I think that's very interesting as well. We see that sort of play out right here at GitHub with things like Cloud Code commits. This is one of my podcast guests showing that some indication of the amount of code on GitHub written by Cloud Code, which you know because they have very clear attribution. This is rising to 4 to 5% as of February. It's probably 10% right now. It's on the trend to be 50% by end of this year. I'm not kidding, guys. That is Cloud Code, but also obviously think about Codex and Copilot and all the other coding agents as well. I did release a podcast with the GitHub COO yesterday. Let me see, where the number that he was presenting was something like 14%. 14x. I'm trying to figure out where the quote is. Year on year, the amount of commit growth from the number from last year is 14,000 times. I think that's really interesting, and I think that's like a sign of things to come. But also, I wanted to also tell you that like there's agents that are doing this for coding, but also there are agents that are doing this for unverifiable domains, like just general browsing and computer use, but also for design. And I do think like that is starting to break out. Like we sort of have this sort of accepted wisdom that it's just going to be for verifiable domains. But I think the beauty of how people are training these models is that it is really generalizing, because that's been the entire focus this whole time. Okay, so what does that mean specifically? I just wanted to sort of dive right into the point of the matter. One of the most prescient talks I ever curated at my conferences is this talk on how the IDE was dying. So Steve 𝗬𝗫𝗍𝗬 is the creator of Gastown. He's a legendary guy. He's the guy who wrote the 𝗬𝗫𝗍's platform rant. Is anyone familiar with the platform rant from Steve 𝗬𝗫𝗍𝗬? Yep. It's really funny thinking about his platform rant and then interviewing Satya yesterday, talking about how he wants to turn Microsoft into an AI platform. I leave you to draw those conclusions yourself. There's a long lore of platform history that I think starts with him and is being written again today for the AI era. But anyway, end of 2026, they did this talk. They said the IDE was going to die in 2026, and they were pretty much true. Like immediately, the sort of everything is conducted carcinization trend basically happened like right after they did it. I think it bodes well on you to then think through the rest of the software development lifecycle. If the IDE is dead, if you're doing all these multi-agent orchestration, like what next, right? Well, the next thing is probably PRs. This concept that you have to sort of wait for someone else to approve manually because you can't be trusted to review your own PRs. I think there's two versions of this. One is the open source version, and one is the sort of internal teams version. Open source version is the one that is most at threat because that's the vector by which a lot of people are sending in malicious PRs or PRs that are not quite aligned to what the maintainers want. So instead of pull requests, you can just send prompt requests, and the maintainers can just adapt it from there because they just need your intent. They don't actually need your code anymore. I think that's really interesting. Beyond PRs, what is after that, right? Like when you have this many agents coding 14 times more than you had last year, what do you actually want to do next? Like a lot of people are exploring these sort of goal loops, right? Like the Ralph Wiggum loop was very viral last year, and now it's basically adopted by every major coding agent. What that is going to lead to is basically this closed loop of coding agents being able to verify their own work. We've been working on this at Cognition, but also a lot of other people are starting to increasingly talk about the depth of the code review. This is what people are calling the dark factory, as opposed to the general light software factory. So if you're familiar with the idea of the token factory or software factory is kind of what people are converging on for producing large quantities of software in some sort of pipeline. The light factory is where there's a lot of humans reviewing it. The dark factory is where there are no more humans reviewing it. And that's very, very scary. I totally understand it. And yet it is coming. Because that is what the multi-agent orchestration future demands, right? That is the bottleneck anymore. So I will I will pause here in case anyone wants to sort of talk about the SDLC. I do have more resources, and I basically I'm repurposing these slides just to bring this up for conversation. But I think you're all here you're all here because you're interested in how people are managing this sort of multi-agent orchestration. Does anyone have like anything that they want to sort of dive into a little bit more on anything I talked about? I was told this was interactive, so I'm being more. Yes.
Yeah. In the SDLC, is the creation of software erodes in the middle, and it becomes more about what are the ideas that we actually need to talk about, and you get into how do you then have user adoption or whatever's on the other side of the pipeline be managed. How are you going to ensure that in the dark factory scenario, what's the hardening at the end, that harness look like? Because it's about ideas and validation and then user change management.
Ideas, validation, user change management. Okay, there's the internal loop and the external loop. I think you're talking more about the external loop of getting user acceptance. Yeah.
Yeah, like we have to have a hardened set of things at the end that we can then prove that the software works.
Yeah.
For audit reasons, compliance reasons,
yeah.
whatever at the end of the loop.
Yeah. So you want to have a strong spec as to what you want to converge to. It really starts to be like sort of one level above just the raw delivery of code, because the prompt becomes how you validate. Yeah, there's a Swiss cheese model. This is one of our top posts of the entire year. By way of introduction, if anyone doesn't know, I run both latent space and AI engineer. We have a good contributor program, and this is one of the top articles of the year so far. The main idea is that, yes, you want to have that sort of spec specification, but also that strong test suite to manage against regressions. I do think it's not enough. I do think that you want to have that sort of outer loop of sort of online eval of like whatever you're shipping and feature flagging so that you have progressive rollouts. Those are all just generally good software engineering practices anyway, whether or not you have a dark factory. I do think they just become way more important because you are suddenly shipping like an Uber, like a Facebook, at your 10-person scale, right? Like you're just sort of bringing forward all these practices of very large engineering organizations because you have a very large engineering organization because you're working with so many agents.
Right, there's got to be some other level if you're going to scale that. You can't scale, they only go so far with humans in the loop. There has to be something that's more scalable, that's higher order that we can use to validate. Yeah, one of our top conversations of the year has been with Ryan 𝗏𝗏𝗏, who is working on sort of the dark factory at OpenAI. Ryan 𝗏𝗏𝗏, so he wrote this article on harness engineering, where it's basically shipping 1 billion tokens a day, which is something like $10,000 a day, and just like no code, no human review as well. And they recently open sourced OpenAI Symphony, which I think I don't know if anyone has looked into, but there's a very strong structure to how they're adopting it. I definitely don't think it is the only way to approach this. There's other people innovating in this dark factory space like StrongDM and others. I do think like you definitely want a strong, like, basically we have superhuman coders, but we don't have superhuman reviewers yet, and mostly because not really the fault of the agents, like we don't communicate enough, right? We don't have that ability of high bandwidth, we don't have the neural link to really plug into the machine and tell them what they want. So obviously the machines are guessing and they guess it wrong. It's not really their fault, not really our fault either. I do think that that just means fast cycles. So for example, even though they have 1 million lines of code and they're shipping a large app, they insist on a compile time of less than a minute, which I've never had in my professional career as an engineer. But because of agents, you can. Like, you can actually take your sort of garbage collection pause every day if you want, and just like make sure you cut all the build times and optimize everything, because why not? But because you have the fast cycles, then you have the fast feedback. And you have the fast feedback, you have the strong alignment between you and the agent, which I think is very important. So I definitely would consider this fringe today, okay? But things that were fringe last year have become normal this year, and I'm trying to update my own learning rate in terms of how this all is going. Because, by the way, this is happening for coding, but a broad lesson that I try to tell people is also that that is actually last year's story. This year's story is that what happened to coding last year is happening for everything else in knowledge work. And that's actually the real story, right? Like, we're using all this sort of multi-agent orchestration conductor thing as a way to basically preview what the future is about to be. Like, we as developers are very privileged because we get to live this first before the rest of the world. By the way, fun fact, the OpenAI team yesterday announced that they're merging Codex into ChatGPT. And so I think this is one of those things where what you see in the coding world is definitely going to bleed into the normal world, which is really fascinating. So I don't know, you can tell your friends on what's coming. Thank you for that. Let me take one more question. I think I had another hand raised somewhere here. Just on the software development lifecycle, the code review side, anything in that domain?
So you mentioned 0% human review. Is that transitioning from 0% human review to just validation of the spec? Because you still mentioned there's some sort of iteration with the human in the loop, or I guess outside of the loop, because you get an artifact to then check.
That does include the validation of the spec. Some of the best utilizations of goal, like, what is goal? Goal is actually, like, you don't tell the agent how to do it. You tell the agent how you're about to evaluate it and when it should stop. And so that is a very primitive form of what you are actually doing as a human. You're just taking the time to write it down. So that is what the sort of Ralph loop or the goal loop is. I do think that there's a few more steps beyond this. So I do think, like, if you look into the harness engineering that OpenAI Symphony is doing, that is the shape of the future, where you have basically a very highly detailed spec. Have you seen this? Have you guys seen this? I'm going to pull it up. Symphony, where's the link? Here we go. It is just a giant list of markdown files, which is really fascinating. I'll just so they sort of really track down everything in here and specify right down to the list. You're really programming with Markdown and English, which is really funny. But really, like, what you're focusing on is the narrow waist of any program, which is the API contracts, the surfaces between modules, the types and data structures, right? Because everything else can be figured out from there. But this is having a narrow waist helps you contain the entropy that models can inherently cause, and also gives you some way to verify that you're not veering too far off of course. Like, so this is, like, the best way that we have found. By the way, this is like 2,000 lines of just prompts. This is the best way that we found so far to write a spec. This is a gold standard spec. Most of us don't do this, right? I don't do this. I write 200 lines if I'm lucky. But I do think that is some idea of the shape of things to come if you want this to be fully automated. We are eventually, like, I think the sort of ultimate Microsoft vision is that right now you are using frontier models like the GPTs and the Claudes or whatever, but ultimately you will have your own personal or your company model trained on your spec anyway, and then you don't have to use the expensive models, right? So, like, I think that is the Microsoft vision. We're not there yet, but I do think, like, if you have a good agent platform, it is meant to be your friend, not OpenAI's friend. You know what I mean? Like, someone needs to be on your side, and I do think that the agent labs versus the model labs. That is the central debate that I do talk about. If you're interested, agent lab here. This is the agent labs versus model labs debate. If you're interested in reading up on that. Cool. Thank you for that.
Thank you.
All right, I'm gonna keep going. I do think like there's a little bit more in terms like if you explore the implications of the SLC. I strongly recommend Steve Yeagy's post on Gastown. If you're interested in like the 8 levels of the fully LLM psychosis sort of approach, let me just find that visual that I always refer to. Yeah, there we go. See, I look it up all the time, and usually I don't have the Q&A time because usually this talk is done in 15 minutes, but I get to stretch it out a little bit more. So roughly this kind of progression, right? Like that you have, you start from like adopting a single coding agent to then doing multi-agent. This is roughly where most of us in this room are if you're sort of up to speed. If you're not, be informed that that's where most people are. And then going out to building your own orchestrator, which Steve Yeagy is doing with Gas City now instead of Gastown. Check it, definitely check it out. But also, you know, he's well aware that he's ahead of where most people are. But literally, this was November, right, when he said this. And it became true round about March, right? It's not that far ahead, guys. It's not that far. Okay. The other thing that I've been covering a lot is really the need for sandboxes. This is one of those things where, again, it's not a sexy machine learning topic like GRPO or reinforcement learning. Just, I need more computer. Because why? My agents need computer. Because why? I need to fork these things in safe environments. And just like, you know, spinning up a new Git branch doesn't do it for me, right? Like I need a full fork of my entire environment. And so this is the Kubernetes problem on crack, because Kubernetes was meant to keep things alive, but this is meant to be extremely serverless, and our sort of current programming paradigms are not quite adjusted to do that, right? The rough idea now with what agents are doing to our infrastructure, we used to be primarily training, and then we'll do a little bit of inference. The ratio of GPU to CPU is 8:1. This is from, by the way, this is from the CEO of Intel, 𝗦𝗲𝗀𝗀𝗀, in the most recent earnings call. Things are moving with agents to 1-to-1 GPU to CPU. This is why there's a coming CPU shortage, not just the GPU. Quote Sam Altman a few months ago, to a very significant degree, we're an AI inference company now, not just training. Okay, I do think that also, I also want to put you on notice, like what you want to do with multiple parallel, massively multiple agents is you want them to finish as quickly as possible. So at Cognition, we've been working very closely with Cerebras on 𝗦1.5 and 𝗦2 coming up for thousands of tokens per second inference, right? Like if you're not familiar with your own inference speed, you should be, but it's roughly between 50 to 100, let's call it tokens per second. I have seen demos of custom chips, which I'm under NDA. I can't say which company it is. There are public company. Sorry, I can point to Thales, which made a really cool demo this year, which you should definitely check out. This is their tokens inference of everyone else, including NVIDIA H200, B200, Grok, and Cerebras. These are meant to be the fast ones. And Thales is over here at 17,000 tokens per second. This might sound like an exaggeration. It is not. I have seen this myself. We are going to see a world with 300,000 tokens per second inference. And this is not for frontier logic, right? This is for commodity token logic. Right now, and all these demos are Llama 8B. But we're going to see this proceed out to the 30B, to the 70B, eventually to the hundreds of B. And at that point, there's some saturation point at which, for the vast majority of your work, it will basically be functionally instant to have intelligence. And you should basically start to think about how you're going to deploy agents and sub-agents to deal with that, or to make use of that, right? Because this is coming on the infrastructure side. We have made the investments already. It is mathematically going to happen. Okay. Finally, actually, I'm about to transition to sort of more future-facing topics. I'm just basically spelling out what I am extremely highly convinced is happening this year. Like Thales will come up with their full chip, by end of year, and you like imagine what you can do with like a 𝗦𝗲𝗀𝗀𝗀𝗀 2.5 at like 1,000 tokens per second, right? This is one of those things where like I think every 10x changes your usage habits, changes the products that you can make, changes the sort of impact that you're going to have on choosing between open models versus closed. Like anything like that, these are the transitions that are happening on the fundamental level that are changing the way that we at the sort of user level and the product engineering level make our decisions. So I'll pause there. So we just covered like the compute and inference side of things. Any other comments, or you want me to double click on something? Yeah. And feel free to shout, I can just repeat what you said. This is all hardware. Okay. None of this is research as far as the model training people are concerned. This is all optimization.
So what's going to push us from where we are now?
Yeah,
to
that's the next part.
the next model,
our patron saint 𝗬𝗲𝗀𝗃 is going to tell us. But yeah, I think it's a fair question. Look, actually, the most interesting research comes from the image community, like the video gen and the image gen community, as far as speed is concerned. So far on the language and coding model community, not really that involved beyond just raw quantization and research into like numerical precision and what have you. It is all hardware. And making smarter choices on with billions of dollars. It is the highest stakes poker game that I've ever seen. Yeah, I think it's a reasonable question. Oh, I will mention more on the research domain later. But I do think that like all these trends are basically pointing us as users, as sort of end user programmers and product people to think very differently about how we utilize them, right? If you understand the Moore's law here, then you start to know like, okay, like this is a cool demo now, but like actually it's going to be normal a year from now. We should probably start planning for it. Yeah. Yeah.
As far as compute, so like training versus inference.
Yeah.
And in part of that talk, it kind of made me think about this. If you have the AI model etched on the silicon, in the typical hardware lifecycle is supposed to be 5 or 6 years. When that model is maybe irrelevant a year from then,
yeah.
How does that shake out?
So okay, there's a leap here which I don't think people have looked into that much. Most of these guys are not etching the actual weights onto the silicon. The only people doing that are Thales right now. So actually, the specialized inference people, there was a whole generation of them that kind of failed to work. Let's just call it. And now there's the second generation is the Cerebrus and Grok that are getting paid. The third generation are still doing it white hat by not doing the short-term win here of burning the weights in. What was the question on that? I do think that the tail is very long. There's still people using GPT-4.1. There's still people using Llama 3, right? And because people build a working application, the whole point of having open weights is that you own the weights and they don't move your cheese. And if the application works fine, why change it? Why it only gets cheaper, it only gets faster, that's fantastic. So I do think the terminal value of a chip is increasing. We used to model, we used to do some tokenomics 2 years ago on latent space, and it was something like your amortization of a chip would be 3 to 4 years. Now it's probably extended in life to 8. The average price of a H100 has melted up. I think I have a time series here. Give me 1 second to find it. By the way, I love using Google for my blog. It's fantastic. Only if you have the SEO for it. This used to be the norm for chip deprecation. And so it was kind of like a hot potato. Then like you would never start a neo cloud based on this. And then chips started doing this. This is like a 4-year-old chip. And because we are figuring out how to make the most out of the inference on older chips, and they are general purpose enough that you can sort of just change the software and update the new models. I do think like there's a fundamental limit to amount of compression that you can have, and so the model sizes are getting larger. Any prizes for guessing? Do you know how big Mistral Small is? we had the chief research officer chief scientist of Mistral on the podcast. 24B is small these days. So we're slowly rising. This used to be 2B, 1B, then went up to 7, 8B, and now 24B is small. I think at some point there'll be like 100B that's considered small. Because at the top end, we have gone from, let's say, GPT-4 being like a trillion tokens, a trillion params, now to 10 plus for the Mythos class. And I think that is very normal and okay. We're not going to have that many orders of magnitude left to go. The rest is the domain of research. I have 4 minutes to cover that. Let's go into that a little bit. What's coming, right? We have all this guaranteed done. You can sort of set your clocks by it for the next 2 years, okay? What's coming is all the other stuff, okay? So there's a king, okay, so this is the research agenda. As far as I get it, as far as I'm tracking it for all the sort of my researcher friends that I'm getting. By the way, I think this is all recorded, which is why I need to rotate my GitHub tokens. But the king one, okay, they're not all equal weighted, okay? Some of them, like memory and continual learning, you're probably going to hear about for the next 5 years and still see not a huge significant change because it's very speculative. The one that is happening right freaking now is real time. And what do I mean by real time? It is that low latency voice that we were all promised with the GPT-4.0 demo that we never got. I wrote this article on the semi-async valley of death at Cognition, where you basically have this sort of uncanny valley area of latency where you're just sitting around watching the AI do its thing, but not really thinking, not really adding value, because you can't really context switch. So either you want to stay in flow and be really fast, or you want to be super async, and there's really no room in between. But that's kind of how you want to work with these multi-agent orchestration things, right? You want to be able to dispatch things in the background and have a good system for working with them, but then have a main thread that is your deep work, that is your focus, that is your highest, most challenging, most valuable task. Because everything else goes to commodity inference. This one, the deep work, the high bandwidth inference, that is something that you definitely want as well. And we honestly have not got, right? Like, think about all the advances in models that you've seen in the past, let's call it 2 years. It's just increasing reasoning, right? Like, we pride ourselves on going from like 2 hours of autonomy to 15 hours of autonomy. Great, but what about my what about taking my 2,000 milliseconds down to 200 milliseconds, down to 20 milliseconds, right? The only people doing this right now are thinking machines. I highly recommend checking out the interaction small models. They haven't actually released this, so all you get is demo videos. But I do think they put the world on notice that there is alpha here, and I do think that that is something that we're seeing as well, right? So you can cheat on the hardware by investing a ton in chips and going, all right, I'll get the chip that gives me 300,000 tokens per second, and in that way get the latency that I seek, but it's not truly interactive. It is still going to try to inference 100,000 output reasoning tokens before giving you your output. But here, truly interactive meaning it has micro batches of interaction modeled in the training data itself. And I do think that that is something that we definitely want to see more of. Like, we want to see that live interaction and mind meld between the human and machine. It will seem smarter just because it will better align with what we wanted anyway. Okay, broader research. The other thing that we just had an XAI podcast as well. The degree to which agents are eating everything is enormous. Right now, people think video generation is just like you put a prompt into a video gen model, and it spits out a video in one pass through that video model. It is about to be video agents, where agents are orchestrating that video model. That sounds cheap. That sounds like, oh, I could do that. But no, I don't think you have fully appreciated what it means to fully end-to-end train the orchestrator for specific domains like video agents, and similarly for all other modalities. I think world models is the other dark horse that I want to point you out to, in the sense of like, the models are currently trying to predict what what sort of like the median RLHF person is, or the RL environment is likely to reward. But them maintaining a world model of what you want, what you like, is effectively that second level of intelligence of like presence of mind and theory of mind that I think is really lacking in the space. So there's all these research directions. solving each and every one of these will lead to changes in the way that we use the models themselves. I do think that this is one of those things where that's hallway conversation as far as we're concerned, but I can definitely see like in the research communities that I track, these are like the sort of top grand prizes right now. Okay, so I think my time is up. The last thing I'll say is I've been calling this sort of the agent work paradox. Agents are doing more work than ever before, but we're also working all harder than we've ever worked before. And that is okay, that's normal, right? I just want to normalize that because I'm also stressed out. I think you guys also all feel it. And that's something that's like common. It is rewarding because we are the first to feel it, and we are getting the sort of brunt of the sort of compression of the future, right? And so this is why I always argue in a very self-serving way that AI engineering is the last job, because you're the ones to automate all the other jobs away. So you guys are in good hands. Thank you.